Take a moment and feel the ground beneath your feet. It feels solid, dependable. It's the very definition of stability, the foundation upon which we've built our entire world. We map its continents, drill into its crust, and chart its oceans, all with the comforting assumption that the planet itself is a constant, a quiet, predictable sphere of rock and metal, spinning reliably in the void. This is the ultimate illusion of safety. We are told in school that the Earth is a simple, layered system: a crust, a mantle, an outer core, an inner core, a neat diagram, clean and orderly. It is a promise of geological permanence. But that promise is a lie. Deep beneath us, 2,900 kilometers down, the heart of our world is changing. In recent years, scientists monitoring the faint seismic echoes that ripple through the planet have detected something deeply unsettling. The Earth's solid inner core, a superheated ball of iron and nickel larger than the planet Pluto, appears to be slowing down. It has stopped spinning in lockstep with the rest of the planet. Some studies even suggest it may have paused and started spinning the other way. This isn't a geological event unfolding over millions of years. This is happening now, in our lifetimes. The engine of our world is not the steady, reliable machine we believed it to be. It's a chaotic, unpredictable system, and it is sending us warning signs that we are only just beginning to decipher. So, what are the strange new signals coming from the center of our planet? And what do they mean for the fragile shield that protects every living thing from the lethal radiation of space? Let's investigate. I'm building a community of folks who want to see past the hype and understand the real risks in this modern world. If that sounds like you, hit that subscribe button. The first anomaly we need to understand is this planetary stutter. Why is the heart of our planet seemingly changing its rhythm? The answer lies in the very structure of the Earth, a design that is far from simple. The solid inner core is not physically attached to the rest of the planet. It floats freely within the molten liquid iron of the outer core. Think of it like a metal ball bearing spinning inside a spherical container of thick oil. The inner core's spin is driven by the immense magnetic forces generated by the churning liquid outer core, while it's simultaneously being dragged and slowed by the gravitational pull of the dense mantle above it. For decades, our models assumed these two forces were in a stable, long-term balance, causing the inner core to spin just slightly faster than the surface. That assumption was the systemic flaw in our thinking. It was a flaw born of necessity. We cannot see the core. We cannot sample it. Every piece of data we have is indirect, derived from analyzing how earthquake waves bend and change speed as they pass through the planet's center. It's like trying to understand the intricate workings of a clock by only listening to its ticking from another room. Our models were elegant, but they were oversimplified. The real system is far messier. The new data suggests the magnetic and gravitational forces are in a delicate, oscillating tug of war. The balance can shift. The statistic is a change in the length of a day, measured in thousandths of a second. It sounds trivial, but the casualty is precision. Our entire modern world runs on it. Consider the global positioning system. The GPS satellites in orbit rely on atomic clocks that are accurate to within a few nanoseconds. To calculate your position on Earth, the system must account for the planet's precise rotational speed. If that speed changes unpredictably, if the length of a day fluctuates in ways our models didn't foresee, the calculations begin to drift. Imagine a commercial airliner on a transatlantic flight. Its navigation is guided by GPS. A tiny timing discrepancy, a few milliseconds born from a change, deep in the Earth's core, could translate into a navigational error of several meters. Over thousands of miles, that error compounds. the plane might still land safely. But what about an autonomous drone delivery system or a high-speed train network controlled by satellite timing? The casualty isn't a single person. It's the integrity of the synchronized, hyper-efficient systems we now depend on for global commerce, communication, and transportation. The stuttering engine in the deep earth is a direct threat to the fragile digital clockwork we've built on the surface. We trusted the clock of the planet to be constant. It is not. This change in rotation is only a symptom. The true danger lies in what it tells us about the source of the problem, the geodynamo. And that leads us to the second, more urgent threat. The shield that protects us is leaking. The Earth's magnetic field is not a permanent feature. It is generated by the chaotic, swirling motion of the liquid iron in the outer core. This process, called the geodynamo, creates a protective bubble around our planet, the magnetosphere. This shield deflects the solar wind, a constant stream of charged particles from the sun. Without it, these particles would strip away our atmosphere and boil our oceans. Life on Earth would be impossible. We live and have always lived under the protection of this invisible field. The illusion of safety is that we assume this shield is invincible. It is not. It is weakening. Measurements taken over the last 2 centuries show the magnetic field's overall strength has declined by nearly 10%. The rate of decay appears to be accelerating. This isn't a uniform weakening. A vast area of profound magnetic weakness has developed, stretching from Africa to South America. It's called the South Atlantic Anomaly. Here, the field is so weak that the shield is, in effect, leaking. Satellites passing through this region are bombarded with high-energy radiation, forcing operators to shut down sensitive electronics to prevent them from being fried. The Hubble Space Telescope cannot take observations when it passes through the anomaly. The systemic flaw is the geodynamo itself. It's not a stable generator. It is a chaotic, turbulent system that is inherently unpredictable. Over geological time, it fluctuates wildly. Sometimes it breaks down almost completely and then reverses polarity, with magnetic north and south swapping places. These reversals are written in the magnetic alignment of ancient rocks. They are a normal part of the planet's life cycle, but normal in geological terms is catastrophic in human terms. A full reversal could take centuries, and during that time, the shield could weaken to a fraction of its current strength. The statistic is a 90% reduction in the field's intensity during a reversal. The casualty is modern civilization. In 1859, before the world was wired, a massive solar storm called the Carrington Event struck the Earth. The planet's magnetic shield was slammed by a wave of solar plasma. The resulting geomagnetic storm was so powerful it induced electrical currents in telegraph lines, shocking operators and setting telegraph paper on fire. It was a curiosity. Today, a Carrington-class event striking a planet with a significantly weakened shield would not be a curiosity. It would be a civilization-ending catastrophe. The initial blast of radiation would disable or destroy most of our orbiting satellites, wiping out global communications and navigation systems overnight. Hours later, the induced geomagnetic currents would surge through our electrical grids. The NTSB's final report on a 2003 blackout in the northeastern United States was damning. It concluded, quote, "The system demonstrated a clear vulnerability to cascading failures. A solar superstorm would trigger a cascading failure on a global scale. Transformers would explode. Power stations would burn. The grid would not just go down. It would be physically destroyed." Think of Sarah, a type 1 diabetic living in Chicago. Her life depends on a continuous supply of insulin. kept refrigerated, and an electronic glucose monitor. When the grid collapses, her refrigerator stops. Her monitor dies. Pharmacies are dark. Hospitals are overwhelmed, running on backup generators for a few days at most. There is no communication, no transport, no power. Her personal life or death crisis is replicated a billion times over for anyone who relies on modern medicine, refrigerated food, clean water pumped by electric motors, or any part of the complex, fragile infrastructure that electricity makes possible. The greatest threat to our world isn't a bomb or a virus. It's a burst of energy from our own star, striking a planet whose shield is faltering from the inside out. So, we have a stuttering engine and a leaking shield. But the investigation reveals a third, stranger element. There are unknown objects interfering with the system. Massive continent-sized intruders at the very bottom of the mantle. For decades, seismologists have mapped two colossal structures sitting on top of the outer core, almost like thermal blankets. They are known as Large Low Shear Velocity Provinces, or LLSVPs. One is buried deep beneath the Pacific Ocean, the other beneath Africa and parts of the Atlantic. These are not simple features. They are enormous, thousands of kilometers across and 1,000 kilometers thick. When seismic waves enter them, they slow down dramatically, indicating that these blobs are hotter and denser than the surrounding mantle rock. The systemic flaw here is a profound gap in our knowledge. We simply do not know what they are. The leading theory is as unsettling as it is incredible. Billions of years ago, a Mars-sized planet named Theia is thought to have collided with the early Earth. That impact blasted debris into orbit that eventually formed our moon. The theory suggests that large fragments of Theia's dense, iron-rich mantle plunged deep into our own planet, eventually settling on top of the core. These two blobs may be the planetary graveyards, the literal alien remains of another world buried inside our own. This isn't just a geological curiosity. These blobs have catastrophic consequences. Because they are hot, they are believed to be the anchor points for massive mantle plumes, columns of superheated rock that rise to the surface and cause supervolcanic eruptions. The African LLSVP, for instance, is directly linked to the volcanic activity that created the East African Rift Valley. The statistic is the size of the Siberian Traps, a region of volcanic rock in Russia covering 2 million square kilometers. The casualty was nearly all life on Earth. 252 million years ago, a mantle plume, likely originating from one of these blobs, burned through the Earth's crust. It triggered an eruption so vast it lasted for 1 million years. It covered a region larger than Europe in lava. The eruption released trillions of tons of carbon dioxide and sulfur dioxide into the atmosphere, triggering runaway global warming and turning the oceans acidic. The event is known as the Great Dying. It wiped out an estimated 96% of all marine species and 70% of terrestrial vertebrate species. It is the closest life on this planet has ever come to being completely extinguished. Those continent-sized blobs aren't just passive features. They are the potential source of past and future mass extinctions, a hidden danger that directly connects the chaos at the core mantle boundary to the survival of life on the surface. There is one final anomaly, perhaps the most disturbing of all. It combines all the other elements: the strange behavior, the hidden structures, the fundamental instability. The very heart of our planet, the solid inner core, is lopsided. It's melting and growing at the same time. The inner core is a crystal, a gigantic planet-sized crystal of iron that is slowly growing as the liquid outer core cools and solidifies onto its surface. For years, we assumed this was a uniform process like a perfect snowflake growing symmetrically in all directions. That assumption was wrong. Recent, incredibly detailed seismic analysis has revealed a shocking imbalance. On one side of the planet, under Indonesia's Banda Sea, new iron crystals are forming rapidly, adding to the inner core's mass. On the opposite side, under Brazil, the inner core appears to be melting. The solid heart of our planet is growing on one side and dissolving on the other. So, what is causing this bizarre asymmetrical behavior? The answer lies with the intruders. The two massive LLSVP blobs sitting on the core are not distributed evenly. They act like giant insulators, trapping heat inside the core in some places and allowing it to escape in others. This uneven heat flow creates a chaotic, lopsided dynamic. The engine isn't just stuttering, it's off balance. The growth of the planet's heart is being warped by the presence of these ancient buried structures. This isn't just a technical detail for geophysicists. The stable, symmetrical growth of the inner core is a key ingredient in maintaining a stable geodynamo and a healthy magnetic field. A lopsided, unstable core introduces a massive element of unpredictability into the entire system. It could be another factor accelerating the decay of our magnetic shield. A 2022 study in Nature concluded, quote, "The long-term consequences of this asymmetric growth on the Earth's magnetic field are poorly understood, but are likely to be significant." The story here is of the scientists themselves, spending years listening to the faintest planetary whispers, the echoes of earthquakes from the other side of the world. They painstakingly build a picture of a system that is more complex and more volatile than we ever imagined. They are the ones who have discovered the design flaw in our own planet. The core's rotation is not stable, the magnetic shield is not permanent, the deep mantle is not uniform, and the heart of the planet is not whole. Knowing these risks isn't about panicking. Fear without action is useless. This is about understanding the real nature of our world and preparing for the consequences. It's about empowerment. The companies that run our power grids and the authorities that are supposed to protect us won't tell you this, but there are simple steps you can take to build resilience against the primary threat, the failure of our electrical infrastructure. First, create a personal resilience plan. The single most likely consequence of this deep Earth chaos is a long-term, large-scale power outage caused by a solar storm. You need to be prepared for that. This isn't about being a doomsday prepper. It's about basic prudence. Have a stock of non-perishable food and, most importantly, several gallons of stored water per person. Have a non-electric way to cook. Have flashlights, batteries, and a hand crank radio to receive emergency broadcasts. Create a plan with your family for how you will communicate if the phones and internet are down. This isn't paranoia, it's practical. Second, become an informed citizen. The science of geophysics and space weather is complex and often sensationalized. Don't rely on tabloid headlines. Follow the primary sources. NASA's Heliophysics Division, the U.S. Geological Survey, and NOAA's Space Weather Prediction Center provide sober, reliable data for the public. Understanding the real science is the first step to demanding real action. Knowledge protects you from both the danger and the fear-mongering. Third, advocate for infrastructure resilience. The electrical grid was not built to withstand a major geomagnetic storm. It can be hardened. Technologies exist to protect large transformers from geomagnetically induced currents. We need to demand that our utility companies and our governments invest in these upgrades. Contact your elected officials. Ask them what the plan is for hardening the grid in your state. Your safety is not their top priority unless you make it their top priority. They will prioritize profits and expediency over resilience every time. These planetary scale dangers can make us feel powerless, but we are not. The Earth is not a safe, static home. It is a dynamic, powerful, and sometimes violent system. Our illusion of safety comes from the brevity of a human lifespan compared to the slow, relentless pace of geological time. But that pace is quickening. The changes in the core are a reminder that our complacent trust in the systems that support us, whether they are natural or man-made, is our greatest vulnerability. True safety isn't found in ignorance. It is built, piece by piece, with knowledge, preparation, and a healthy dose of skepticism. The ground beneath your feet is not as solid as you think. You need to be.